Okay, so welcome back, and now what we're going to do is we're going to do this proof, and in this proof we're going to prove that if the limit of f of x as x approaches a is equal to L, and the limit as x approaches a of g of x is equal to m, then the limit as x approaches a of the sum of those two functions will result in L plus m. Okay? We've talked about this before, but now we're going to prove it using the delta epsilon proof. Okay, so now we are going to use the triangle inequality in this case, because what we have to do is we start with what? We start with the absolute value of f of x. So here's my scratch work. Okay, so plus g of x minus L plus m. We want that to be less than epsilon. Okay, now I'm going to rearrange this, and I'm going to write this as f of x minus L plus g of x minus m, absolute value is less than epsilon. Now, here's where we're going to use the triangle inequality, because this is positive real number, okay? But also we're assuming epsilon is greater than 0, so obviously positive, okay? Which means that we have positive numbers in here, okay? Because these are distances, right? And distances are always positive. Okay, so, well, you'll see using the triangle inequality, we're going to get positive numbers anyway. So distances may not always be positive, so I kind of fibbed there. But notice here, I'm going to write something here, because I'm going to say this, we know from the triangle inequality, is less than or equal to f of x minus L plus the absolute value of g of x, minus m, right? We know this is less than or equal to this, which is then going to be less than epsilon. So now, what are we going to do? How do we choose our delta? Well, here I'm going to say if this is less than epsilon over 2, and this is also less than epsilon over 2, right? Then those combined will be less than epsilon. Okay, so now, okay. So now let's do our proof. So now I want to do... Yes. Okay, so now, let's do our proof. Now that we've worked that out on scratch paper, let's do our proof. So what I'm going to do is, here's the proof. Okay, so we're going to let epsilon be greater than 0. Choose do I want to stop there? Hold on a second. Yeah, so I want to choose delta 1, oops, greater than 0. So that if 0 is less than the absolute value of x minus a is less than delta 1, then f of x minus L will be less than epsilon over 2. Choose delta 2 greater than 0 so that if 0 is less than the absolute value of x minus a is less than delta 2, then the absolute value of g of x minus m will be less than epsilon over 2. And then what we're going to do is we're going to choose delta. Okay, so now this is where, so we're going to choose, do I want to choose there? Yeah, so choose delta to equal the minimum of, oops, delta 1 and delta 2, right? So now, if I choose delta to be the minimum of both of these, well, guess what? Then both of these will be satisfied, okay? So now, assume that 0 is less than the absolute value of x minus a, which is less than delta. Which means, thus, 0 is less than the absolute value of x minus a is less than delta 1, and 0 is less than the absolute value of x minus a is less than delta 2. Now, hence, okay, now we put it together, and what do we get? We have absolute value of f of x plus g of x minus L plus M, right? Which then is equal to the absolute value of f of x minus L plus g of x minus M, right? And then, let's go back up here. Then, that's going to be less than or equal to the absolute value of f of x minus L plus the absolute value of g of x minus M, which, guess what, is less than epsilon over 2 plus epsilon over 2, which equals epsilon. And that's the result. That's it. Have a great day.